So शुरू करते हैं what is sound. Now in our environment जब भी ज़्यादा प्रेशर बढ़ जाता है या ज़्यादा डेंसिटी हो जाती है या लो प्रेशर लो डेंसिटी there is a change in energy, okay, and that change in energy is in the form of waves, and those waves are called as sound. So sound is a form of energy. So sound waves give rise to a chain of compression, which is high density, and rarefaction, which is a place of lower density. Also the waves दो तरीके के होते हैं, longitudinal waves and transverse waves. अब sound के साथ जो terminologies use होती है, let's have a look. First is the wavelength. Wavelength is nothing but जहाँ से wave शुरू होती है और जहाँ पे एक wave ख़त्म होती है. So it is the distance of the wave. Then it is denoted by lambda, so that's the symbol. Then you have frequency. Frequency is denoted by the letter symbol nu. Then you have amplitude. Amplitude is maximum density या maximum pressure होता है, that is amplitude. And then you have time t. अब sound related जो formulas है, let's have a look at that. So what is velocity of a sound? It is equal to distance upon time. So velocity of a sound define कैसे करेंगे? It is the distance covered by a point on the wave in unit time. That is called the velocity of the sound. Sound के case में distance यानी wavelength and time is equal to time. Formula is lambda upon t. If you separate t out, you get lambda bracket 1 upon t, and 1 upon t is equal to the frequency. So let's substitute this in the formula above. You get lambda into nu. So therefore the velocity of the sound, uska formula hai wavelength into frequency. A very important point, for sound to propagate or sound to traverse, it requires a medium. Without a medium, sound waves will not travel. Now the medium could be a solid, it could be a liquid, or it could be a gaseous material. Important point to remember, velocity of sound is highest in solids and least in gases. The reason is, in solids the materials are placed very close to each other, they are very tightly coupled. So sound को एक अच्छा medium मिल जाता है traverse करने के लिए. Whereas in gases the materials are placed at quite some distance. So therefore it takes time for the sound waves to traverse. Also, the velocity of sound in the gaseous medium depends on temperature, density and molecular weight. Velocity is directly proportional to square root of t. As the temperature increases, velocity will increase. So it's called directly proportional. Velocity is inversely proportional to the square root of density. If the density increases, velocity will decrease. So it is inversely proportional. Velocity is inversely proportional to the molecular weight. So if the molecular weight increases, the velocity will decrease. Now let's solve this sum. How long will it take for a sound wave of 25 centimeter wavelength and 1.5 kilohertz frequency to travel a distance of 1.5 kilometers? So let's write what is given. Wavelength, that is lambda, is given as 25 centimeter. Frequency is 1.5 kilohertz. That is nu. The symbol is for frequency is nu. And let's convert it into hertz. SI unit of frequency is hertz, and same for lambda is meters. So 25 centimeter is 0.25 meters, 1 meter is 100 centimeters, and 1 kilohertz is equal to 1000 hertz, that is 10 raised to 3. And the distance is equal to 1.5 kilometers. Let's also convert this kilometers into meters. So it will be 1.5 into 10 raised to 3 meters. And to find is, how long will it take? So you need to find the time, t. So the formula to be used is velocity is equal to Distance upon time. So we have the distance, but we don't have the time, neither do we have the velocity. So first what we'll do, we'll find the velocity. And the formula to be used is velocity is equal to lambda into frequency. Now we know the values of lambda, so let's substitute, that is 0.25, and frequency was 1.5 into 10 raised to 3. So let's just do the calculations. Multiply 15 by 25. Now put the decimal after 3 places. So you get 375 and then 3 zeros for 10 raised to 3. So that gives us 375 velocity. So it's going to be meter per second. So now let's substitute velocity in the earlier formula. So you have 375 is equal to, distance is 1.5 into 10 raised to 3 upon t. So you get time is equal to 4 seconds. The sound wave thus takes 4 seconds to travel a distance of 1.5 kilometers. From your textbook, the molecular weight of oxygen is 32 and that of hydrogen is 2. So let's write what is given. Molecular weight, let's assume the molecular weight for oxygen is MO. So MO is equal to 32, and for hydrogen MH, that is given as 2. Prove that under the same physical condition, the velocity of sound in hydrogen is 4 times that in oxygen. So let's write what is to prove. So velocity of hydrogen, so that will be VH. Let's assume that VH is equal to 4 times. So 4 times is 4 multiplied by velocity in hydrogen, that is VO. So this is what you have to prove. We know that velocity is inversely proportional to square root of m, that is molecular weight. Now let's substitute that for oxygen. So we have VO is equal to 1 upon square root of 32. And when we convert inversely proportional to equal to, you have to assume some constant k, right? So you have VO is equal to k upon 1 upon square root of 32. 32 is 4 comes out, 16 twos are, so 4 and square root of 2. Now let's do the same for hydrogen as well. So you have velocity is inversely proportional to 1 upon h. So you have VH is equal to 1 upon square root of 2. Now since we are converting the inversely proportional to equal to, we have to assume the constant k. So now we have VH is equal to k 1 upon square root of 2. Let's substitute this value in the equation above. So you have, so k 1 upon square root of 2 is common, right? So let's just substitute that in the equation. So you have VO is equal to, so 4 1 upon square root of 2 is VH. So you have VH upon 4. Just do the cross multiplication and then you get 4 VO is equal to VH. Hence proved. VH is equal to 4 times VO.